Hello again, everyone, and welcome to one last video lecture for week 6 of Psych 370. In this one, I'm going to be talking about a phenomenon called conditioned taste aversion, and you've probably experienced this before. So conditioned taste aversion is what we call it. When you eat something or drink something, then you get sick to your stomach later, and even if you know that the food or the drink didn't actually cause your nausea, you will still associate it with your nausea. And so you'll acquire an aversion to it. So you'll actively avoid it in the future because the taste of it or even just the smell of it will elicit that sick, nauseated feeling from you as a conditioned response. So again, we call that conditioned taste aversion, and that's what I'll be talking about in this video lecture. Now, guys, the classic research on conditioned taste aversion was conducted by this guy, a man named John Garcia, no relation to Jerry, by the way. The beard made me think that was a possibility, so I Googled it, but they're not related. And what inspired this research that John Garcia did was an experience that he had when he was a boy, when he got sick to his stomach after he ate some licorice, and then later found that he could no longer eat licorice because the taste of it nauseated him. Now, he knew it wasn't the licorice that had actually made him sick. He knew that he'd had the flu. He knew that's what actually caused his nausea. But he still acquired an aversion to the taste of licorice. The taste of it and the smell of it still elicited that sick, nauseated feeling. So he came to avoid that food. So, years later, Garcia conducted a classic experiment with a colleague named Robert Colling. Now, the experiment was conducted using rats as subjects. And what Garcia and Colling did first was they allowed their rats to taste some distinctively flavored water. Okay, the water had been sweetened with an artificial sweetener called saccharin. And whenever the rats drank that water, they'd also see a flashing light and they'd hear a clicking noise. So, in other words, every time these rats licked the spouts of their water bottles, that caused the light to come on and it also caused the noise to occur. So, Garcia and Colling referred to this as bright, noisy, sweet water. Okay, because there's a bright light, there's a noisy sound, and there's this sweet taste that the rats experience all at the same time. So, in other words, that bright light, that noisy sound, and that sweet taste formed a compound stimulus, right? And that compound stimulus served as the conditioned stimulus in this experiment. So that's what all the rats got presented with first. They all got this bright, noisy, sweet water first. That compound stimulus is the conditioned stimulus here. Now, for some of the rats in this experiment, the unconditioned stimulus was electric shock, but for others, the unconditioned stimulus was exposure to radiation, which causes nausea. So some of the rats would drink the bright, noisy, sweet water and then get shocked. So for some of the rats, the bright, noisy, sweet water got paired with electric shock, but for others, it got paired with radiation. So other rats would drink the bright, noisy, sweet water and then be made sick through exposure to the radiation. Okay? So same CS for all of the rats, but a different US for these two different groups. Then what Garcia and Colling did was they gave all of the rats a choice between two water bottles. One that contained sweet water, but that didn't trigger the noise or the light, and one that contained plain water, but that did still trigger the noise and the light. So in other words, now the rats have a choice between sweet water with no light and no sound, or bright, noisy water with no sweet taste. And the results were that the rats who had gotten shocked tended to avoid the bright, noisy water. They instead drank the sweet water. But the rats who got radiation as the US tended to do the opposite. They avoided the sweet water and they drank the bright, noisy water instead. Now, what this suggests, of course, is that during those initial pairings, the rats in that first group did learn to associate the light and the noise with the shocks they received, but they didn't learn to associate the sweet taste with the shocks. So when shock was used as the unconditioned stimulus, the animals did acquire aversions to the light and to the noise, but they didn't acquire an aversion to the sweet taste. That's why they still drank the sweet water. And then, by contrast, the rats in the other group learned to associate the sweet taste with sickness, but they didn't associate the light or the noise with sickness. So, when radiation was used as the unconditioned stimulus, the animals acquired an aversion to the sweet taste, but they didn't acquire aversions to the light or to the noise. So, what Garcia and Kohling concluded from these results is that we are prepared, we are biologically predisposed to associate taste with illness. So, taste and illness kind of belong together, so to speak. We're much more ready to associate a taste with illness than we are to associate other stimuli like sights or sounds with illness. In other words, when we get sick, our natural, biologically predisposed inclination is to blame that sickness on something we ate or something we drank. Forming that association is something that our evolutionary history has prepared us to do. Because after all, foods that make us sick can also harm us or even kill us, right? So it would have been a good idea for our ancestors to avoid the foods that they ate before they got sick, just in case it was the food that was responsible for that sickness. Humans who didn't have that tendency wouldn't have fared very well, right? They would have been more likely to die or fail to reproduce due to food poisoning or other problems. And so the idea here is that we are the descendants of people who readily associated tastes with illnesses and therefore avoided those tastes in the future. In fact, guys, our tendency to associate taste with illness is so strong that we'll do it very quickly, often after only a single pairing of the taste with the illness. And we'll even do it if a long period of time passes in between when we experience the taste and when we experience the illness. And guys, that makes conditioned taste aversion unique compared to most of the other examples of classical conditioning that we've discussed. So usually, the conditioned stimulus and the unconditioned stimulus have to be paired repeatedly, right? And usually, the time interval between them has to be fairly short in order for a conditioned response to be acquired. But that's not the case with conditioned taste aversion. Again, you can acquire a conditioned taste aversion after only a single pairing of the taste with the illness, and you can acquire it even if as many as 24 hours pass between the taste and the illness. And again, this makes sense in the context of natural selection, because after all, if you eat something that really does make you sick, then it doesn't usually make you sick right away, right? It takes time for that illness to set in. And people who started avoiding a food after only one brush with nausea probably would have been better off in terms of fitness than people who had to get sick from a food multiple times before they started avoiding it. So, guys, the point of all this is that people, like most animals, will acquire conditioned taste aversions quite readily. In fact, you can probably think of a conditioned taste aversion that you have. For example, personally, to this day, I cannot eat peanut brittle or drink gin because I have aversions. I have conditioned taste aversions to those things. So, conditioned taste aversions are pretty common. But why are they covered in the applications chapter of your textbook? Well, one reason is because farmers can take advantage of this phenomenon to help protect their crops and their livestock. So, for example, let's say that you're a sheep farmer, okay? You raise and breed sheep, and you've got a problem where all these wild predators like wolves and coyotes keep attacking and eating your sheep. So, you got to do something about these predators who are messing with your sheep. Well, one way that you could deal with that problem would be lethal control, right? I mean, you could just kill the predators. But that obviously brings up moral concerns. Maybe you'd rather not do that. And taking those predators out of the ecosystem could also wind up disrupting that ecosystem, right? So, as an alternative to lethal control, a psychologist named Carl Gustafson reported a method that involved allowing those predators, allowing those wolves and coyotes to eat sheep carcasses, but first lacing those carcasses with lithium chloride, which is a powerful emetic. So it won't kill the animal, but it will make the animal quite sick. And then later, when those wolves and coyotes were presented with live sheep, they didn't attack and eat the sheep like they normally would. So they acted like they had acquired a conditioned taste aversion to the taste and the smell of the sheep. So farmers were quick to see the potential of this method. They began planting that tainted mutton, that poisoned sheep meat, around their farms, which allowed them to solve the problem of losing sheep in a way that not only saved the lives of their sheep, but also those of the wolves and the coyotes. So I'll show you a quick video now about this particular application of classical conditioning.
In this sequence, wolves are shown attacking a sheep. Later, the wolves were made ill by eating lithium chloride hidden in the carcass of a sheep. After they recovered, the wolves were again given the opportunity to kill and eat sheep. Their predatory approach behavior was unchanged, but when they got close, they backed off each time in disgust. Interestingly, sheep, which are normally petrified with fear when a wolf attacks, gradually begin to assert themselves after the wolf backs away several times. Preliminary tests on a sheep ranch indicated that this technique might be useful in reducing the loss of animals to predators such as wolves and coyotes. Since the alternative is to hunt and kill these predatory animals, the use of a conditioned aversion technique may help to preserve our wildlife.
Okay, so again, after the wolves were allowed to eat this tainted meat, after they were allowed to eat this sheep meat that had that emetic planted in it, they acquired conditioned taste aversions to sheep meat, so they stopped attacking the sheep. So it's sort of like the farmers put these wolves through some aversion therapy, right? Where they got them to associate the sheep meat with the lithium chloride. And that was especially effective because of the wolf's natural tendency to acquire aversions to the sheep meat after it was followed by nausea. And guys, similar applications of conditioned taste aversion have also been used to get raccoons to stop attacking chickens, to prevent ravens and crows from going after crane eggs, and even to get geese to stop eating the grass on golf courses. There's also an interesting example on page 112 of your textbook that involves getting sheep to acquire a conditioned taste aversion to grapes so that they would eat the weeds on a farm, but leave the grapevines alone. So, in classical conditioning terms, the taste and the smell of that previously victimized plant or animal is treated as the conditioned stimulus, right? The emetic, the sickness inducing poison, like the lithium chloride, is treated as the unconditioned stimulus. And as a result of pairing those two together, the predators acquire a conditioned response of avoiding those plants or those animals. So that's a pretty neat and clever application of conditioned taste aversion. But of course, one potential drawback to the ease with which we acquire these aversions is that, like I said before, we'll sometimes acquire them even when we know that it wasn't actually that food that made us sick. So remember, in John Garcia's case, he knew it wasn't the licorice that made him sick when he was a boy, right? But he developed an aversion to licorice anyway. And in my case, I know it probably wasn't the peanut brittle itself that made me sick, but I still acquired that aversion to peanut brittle. So even if we don't consciously say, oh, I'm sick, it must have been something I ate, it's sort of like our bodies come to that conclusion on their own. Because that conditioned response, that aversion will kick in anyway as an automatic reflexive response to whatever taste or smell we experienced before we got sick. So guys, this can present a problem sometimes for cancer patients who are undergoing chemotherapy. Because chemotherapy tends to induce nausea, right? So patients will often acquire aversions to the foods that they ate before they went through their chemotherapy sessions. Again, they know consciously that it's actually the chemo that's making them sick, but they acquire those taste aversions anyway. They still lose their desire to eat those foods that they just so happen to pair with the chemo session. And this is a big deal because cancer patients often suffer from things like poor appetite and severe weight loss anyway. And so, if they acquire aversions to foods that they once liked, then that could obviously exacerbate those problems that they're already dealing with. But interestingly, one way to avoid having those conditioned taste aversions come about is to have the person eat a highly novel, highly distinctive food after their most recent meal and before they undergo the chemotherapy. So that way, the novel food is more likely to be what the patient actually associates with the nausea. It becomes a sort of scapegoat, in other words. The idea is that you want the patient to acquire an aversion to that novel food instead of to whatever they ate for the actual meal. And there's evidence that this does work. So, for example, in one study, what the researchers did was they took some children who were undergoing chemotherapy. After those kids ate their regular meals, they gave them these coconut flavored or root beer flavored candies to eat. So the kids eat these distinctively, uniquely flavored candies after their meal and before their chemo session. And what the researchers found was that those kids were much less likely to acquire conditioned taste aversions to the foods that they ate in the actual meal. So, in other words, they seem to associate the candy with the sickness instead of these other more nutritious foods that they ate for the meal. And so, it's interesting that we can apply what we know about conditioned taste aversion to not only bring about those aversions when they're necessary, like in the case of the farming examples, but also to prevent taste aversions from forming when they otherwise might. Okay. So, in this week's lectures, I've talked about a lot of different ways in which the principles of classical conditioning can be applied to help solve important, real world, practical sorts of problems. And there are several more applications of classical conditioning that are described in your textbook. But again, what I hope you take away from this week of the course is that classical conditioning is not just about dogs salivating to bells, right? The applications of it are widespread. And so, knowing more about how classical conditioning works can be a very useful thing. Okay, well, as always, if you have any questions about anything you've heard in these lectures or anything you've read about in the textbook, then please let me know. I'll also remind you that you have an exam this week. So that exam will open up on Friday morning. You'll have until the end of the day on Sunday to take it. And as usual, there's a weekly quiz for you to take and a weekly activity for you to complete. Your next article summary is also available now in Canvas, and that article summary is not due until the end of next week, but of course, you're welcome to get an early start on it this week if you'd like to. But anyway, that's going to do it for this week's video lectures, so please do reach out if you have any questions, and I'll catch you next time. Take care.